This section explains the ControlNet model and code implementation. Let's first look at the ControlNet model overview. ControlNet is a neural network that conditions the output of a diffusion model using an external control signal, such as edge maps, depth maps, segmentation maps. It guides the diffusion process by injecting structured information while preserving the generative power of the base model. In ControlNet, ControlNet takes an input feature tensor X from the diffusion model. It processes a control signal, such as an auxiliary feature map, and refines it through convolutional layers. The refined control signal is added back to X, influencing the output while keeping the base model's behavior stable. Mathematical formulation. The ControlNet function is as follows. X is the feature map from the base diffusion model. C is the control signal, such as edge maps, depth maps. FC is computed via a series of convolutional layers. W is obtained via a channel attention mechanism. Formula derivation, step by step. 1. Extract features from the control signal. W1 is a convolution kernel. B1 is a bias term, and sigma is an activation function, ReLU. 2. Process features through residual block. Each block applies convolution, normalization, and nonlinearity as follows. SF is a skip connection using a 1×1 convolution. 3. Apply channel attention. The attention mechanism computes weights as follows. GAP is global average pooling. W3 is a transformation matrix. 4. Zero initialized output projection. To ensure stable training, a final projection layer is initialized to 0. W4 initialized to zeros. 5. Add control features to input. Finally, the modified feature is added to the base model as follows. Now we implement the ControlNet code. Conv 2D class. ControlNet class. Testing the ControlNet model.